Hi everyone, my name is Paolo Colombo and I'm present you TropiDash, a comprehensive tropical cyclone dashboard for tropical cyclone. Our team is composed by myself, Filippo Dainelli, and Laura Paredes Infortuni. I and Filippo come from the same university in Italy, while Laura is from Spain. And the project purpose arises from some concerns considering the current availability of tropical cyclones risk, hazard information, summarized in single location and dashboards. More in particular, current dashboards lack featuring multiple products coming from multiple sources. The charts represented usually lack interactivity, reducing user experience and exploration of the data displayed. Current dashboards are very specialized, excluding less experienced users from effectively interact with these tools, and expanding the possible data to be visualized and creating different level of complexity in the chart can increase the accessibility of the dashboard to a broader audience. So following these three main limitations, we present the project purpose, which is to build a Jupyter notebook dashboard to help in preparedness and resilience against tropical cyclones events. Let's start with some introductory information regarding the events at the center of our project. So tropical cyclones. Tropical cyclones are intense circular storms that originate over warm tropical oceans. They are characterized by low atmospheric pressure, high winds, and heavy rain. You can see at top an image of a satellite picture of Cyclone Freddy, which occurred in the Southern Indian Ocean last February. On average, about 85 tropical storms occur along the year across the globe. The map in the bottom displays the region of formation and the red general tracks of the storms, which have different names depending on where they occur. Tropical cyclones are much relevant for civil protection because they are big threats to life and property, even in the formative stage of their development. They include a number of different natural hazards that can individually cause significant impacts, like high seas, extreme winds, storm surges, heavy rainfall, tornadoes, and floods. To give you an idea about the impacts, according to the World Meteorological Organization, over the past 50 years, 1,942 natural disasters have been attributed to tropical cyclones, which caused more than 700,000 deaths and 1,400 billion in economic losses. So our project wants to build a dashboard, and the project structure is developed through three milestones. The first milestone covers the gathering of all background information needed for the development of the project itself. And this means having a clear idea of which are the hazards related to tropical cyclone events, which are the relevant indicator of and meteorological parameters for the description, what are the current tools available, and visualizing tropical cyclone hazards and what are the strengths and weaknesses of these tools. So the second milestone ensures a clear design of the platform that we want to develop, listing all the components and how they interact with each other. The topic addressed are how the data sources are assessed, which is the structure of data visualization, and which Jupyter plugins to use. The third milestone is to develop structure platform online with appropriate documentation. This will be the more operational phase where we will implement the design decided by reaching the second milestone updates on the platform. So in the first, which we concluded last month consisted in the recognition and analysis of existing dashboard showing tropical cyclones data. What we have retrieved from this phase is that having too many variables make it harder to understand the dashboard and most important information we can provide. Lightness and speed of the dashboard in providing maps and coverage is important, but maybe the dashboard could be divided into different basins of interest. Summary characteristic for each cyclone position helps in better understanding the data. Impact layers are necessary. Colors are helpful for visualization of intensity categories, and it is overall important to dedicate different plots and charts to variables that cannot be visualized as overlaid to a map. And at last, it can be important to increase complexity of the chart while you scroll through the dashboard, so that experienced user can go to the end of the dashboard, while a non-experienced user can just remain on the on tools that they actually can understand. So from the existing context recognition, we also identified a list of variables and indicators we believe would be important to include in order to have a comprehensive and complete ensemble of information on tropical cyclone visualization. In this slide, we report a few of them. To give an example, we decided to group them in 3 macro areas: cyclone properties, meteorological and ocean variables, and impact variables. So then these variables can be mapped and indicate to assess the possible risks connected to tropical cyclone. To design the platform, we followed these steps. We are now finishing the platform design phase, and at first we understood and decided how the platform will access data. We'll gather ECMWF data through an API. Then we decided on the data visualization structure, deciding the graphs to show. The variables listed before will be plotted in maps and bar plots, depending on the variables, and leaving to the user the possibility to interact with maps and graphs. After exploring possible plugins, we decided to use Voila to deploy the dashboard, as it enables the possibility to be launched by terminal and permits an overall flexible framework to define the dashboard structure. Then we define the dashboard structure and use a user interface by defining how maps and graphs will be shown and accessed by the user. Here we can see a first visual draft on what we expect to obtain as a Jupyter Notebook dashboard, together with the key features we want to have. We'll produce a more precise draft to be included in our second deliverable, but now I'm going to deepen some key features. We want the dashboard to have 5 sections, 3 of them with plots and maps of the different variables categories following the previously cited division, so cyclone properties, atmospheric ocean variables, and impacts. The first as a global section, where the user is able to overlay all the variables present in the dataset, and the fifth one as a map, where the user can choose a location to plot the temporal evolution of some variables. We want to build an interactive widget for the map selection, where the user can choose the latitude and longitude boundaries of the map and automatically visualize a crop of the global map. And we want the dashboard to have different information buttons referring to information menus, a general one and specific one for each section, to improve user experience and understand how to use the dashboard. We want to have a panel reporting all the summary cyclone characteristics as the user selects the event to visualize. For example, most intense category reached, minimum sustained wind speed, maximum sustained wind speed, minimum value of low pressure, and so on. So this is the overall idea of our design. We will, as I said, we will develop more and put it in our second deliverable. But now on the next phase, so the platform design will be finished next Monday on the 10th of July. Then we have scheduled our last milestone to be completed on the 31st of August, actually developing the dashboard, like coding the Jupyter Notebook dashboard and ensuring the maintenance through documentation. Then on the 20th of September, we will have the presentation, the final presentation in Bologna. And now on, if you have questions, I'm here. Thank you so much for your attention.
Thank you, Paolo. Great presentation, and I think a lot of interesting topics to consider to bring into the dashboard. There's a question on the general chat. So Garima is asking if you have noticed any effects of the cyclone on the emission of sea salt aerosols. Not sure if you can answer that question.
I actually cannot answer this question, but maybe my colleagues can, because I don't actually work on cyclones, but maybe if you leave us an email, we can write you, because right now I have no idea how to answer this question. But
yeah. So so far, what was the biggest challenge for you, Filippo and Laura? You would say, okay, this you know, what's the biggest obstacle and we came it, or you know, is there something you can say about that, or everything smooth?
It was everything was actually smooth, but the most difficult thing for me was like to condense all. Because there are a lot of tools already available, which were the good things about these tools, and which were the bad. So to condense all of them and to find out, okay, we want to take the good and leave out the bads. was not that easy, but we managed to do that, and so now we are keen, and we have a good idea on what we want to do, and we are starting now the coding phase, and we have energy, and we will we'll achieve it.
Great, thanks a lot, Paolo and your team.